Welcome to how to differentiate numerically and graphically with the fx-CG100. In this video, we will demonstrate how to find derivative values, graph and analyze Cartesian derivative functions, and solve derivative equations. To start, we will draw this function, representing the position of a particle with respect to time. Press Home and select Graph and Table by scrolling or using the shortcut. To enable easy access to the derivative values when graphed, press Settings. The derivative is turned off by default, so scroll and turn it on with OK. Press Back to close the settings pop-up. Enter the function as a y equals f of x function and confirm. Then Graph with Right tab. From the View window pop-up, we will change the scales to optimize the graph for our function. Enter -1 for the x minimum value, as this will show the y-axis. Then the upper limit 7 for x maximum. To view the complete curve, enter -40 for y minimum, 30 for y maximum, with a scale interval of 10. Use Page Scroll to scroll back to the top of the pop-up. And draw. We can now analyze the graph and find the gradient of the function at any point. Press Tools and select Trace. The decimal coordinate values are shown, together with the value for dy dx. Move the cursor along the function by scrolling. For a particular point, simply enter a value, which opens a pop-up. Confirm to move the cursor to that point. End the trace analysis with Back. Sometimes it could be useful to graph the derivative of a function, which we will now do using a template. Return to the Function tab with Left tab. Then press Catalog. Select Function Analysis and the first derivative. This opens a template to enter a function and point. Either enter the actual derivative function, 12x subtract 3x squared, or use the calculator's functionality. Press Variable and select Function. Then select the stored y1 function. This places the graph notation in the differentiation template. This is an efficient method for sketching the derivative, as simply changing the y1 function will now also change the derivative function. It also allows comparison of accuracy between graphs of your differentiated function and the correct derivative. Enter the general point x to plot the derivative of all points. Then confirm. In addition to the first derivative, we can also use a template to graph the second derivative. The method is as before, so press Catalog. Select Function Analysis, but this time select second derivative, which opened the d2 dx squared template. Again, either enter the second derivative, 12 subtract 6x, or use the graph notation. Press Variable and Function. Select y1 and enter the general point again. Then confirm. All three functions are now stored, so press Right tab to open the pop-up and draw. As expected, a cubic, quadratic, and linear function are drawn. Having drawn these functions, they can now easily be analysed and connections made. To find the maximum of S, press Tools. Select Graph Solve and Maximum Value. As more than one function is drawn, we need to select the function for analysis. Currently, the y1 function is flashing, so select it with OK. The maximum is found at 4, 27 and is confirmed as a stationary point as the displayed dy dx value is 0. Press OK to show the coordinates. To demonstrate the links to the derivative function, end the analysis with back, and press Tools again. This time select Trace, and scroll to select the first derivative function y2. Enter the x value of the maximum 4, and confirm. The first derivative is shown to be 4, 0, confirming the link between stationary points and 0 derivative values. The displayed dy dx value, -12, is the value of the second derivative at this point. The negative value, which can also be seen from the graph, confirms a maximum. Derivative functions can also be used to find other points, such as inflections. End the analysis with back, and press Tools. Select Graph Solve, and then Root. Scroll and select the second derivative y3. Press OK to show the coordinates for the root at 2, 0. This indicates a maximum value of the first derivative at 2, and so an inflection point for s. To find the coordinates of the inflection point, end the analysis. Press Tools and select Trace. Enter the x value 2 and confirm to place the cursor at the inflection point. The position is given as s equals 11, with the dy dx value as the velocity of 12. In addition to analysing functions and derivatives graphically, the Graph and Table app allows easy investigations to be made using table. Press back to end the analysis, and then right tab to open the Table tab. The table is populated with the default values of x, which is suitable for this example. As the derivatives have been turned on, y dash columns are also shown. Scrolling identifies the 0 value for y-1 at x equals 4. Notice the same values populate the y2 column, as it is also the derivative function. Scroll again to identify the root of the second derivative at x equals 2 for the inflection point. As well as graphical analysis, the handset is capable of numerical differentiation calculations. From Home, select Calculate. The functionality is located in the same menu as before, so press Catalog and Function Analysis. Select First Derivative to open the same template. Then enter the function, and enter a specific x value, such as the inflection point. Then execute to find the gradient of the curve at that point. As you would expect, the value of the second derivative can also be found at a point. As before, press Catalog, Function Analysis, and select Second Derivative. Then enter the function, or alternatively, use the graph notation shown earlier, as the function is already stored in Graph and Table. Press Variable, and select Function, then y1, and enter an x value. Then execute, confirming an inflection point. To find a maximum numerically, it is possible to solve an equation containing a derivative template. Press Catalog and Function Analysis. Then select Solve n. This powerful functionality can solve all sorts of equations. If you have not seen this before, then please check out our other resources for more information. Enter the derivative template by pressing Catalog again, then Function Analysis, and First Derivative. Either enter the function directly, or use the graph notation if already stored. As we are trying to find where this derivative equals 0, we need to solve for x, so enter the general point, and execute. Then close the warning to display two values of x, 0 for the minimum and 4 for the maximum. In order to find the value of s at the maximum numerically, it is easy to use the handset functionality instead of a manual calculation. Press Variable and Function to recall the graph notation seen earlier. Select y1 and enter the coordinate value 4 to perform a y1 of 4 calculation. Then execute to confirm the s value of 27. We hope that you have found this video useful. If so, please do check out our other resources on the Casio Education UK website and YouTube.